Now that we've seen the idea of using class attributes, data attributes to give unique names to things or unique identifiers to them, we could start building up a little representation of MIT people. More importantly, given now we've got two classes in our hierarchy, we want to extend it to look at variations on how we inherit methods. So let's add in different kind of MIT people. We have students. They're all MIT people, but they come in different flavors. We have undergraduates who have a class year. We have graduate students who don't have a class year because we can't tell how long it's going to take them to finish up their PhD. Let's add those in. So I can extend my class again. And again, I'm going to start building now on top of MIT person, which I remind you inherits from person, which inherits from the base object class. And UG stands for undergraduate. So an undergraduate has a name. It also has a class year. And as I did before, I'm going to use the inherited, in this case, MIT person method to create the instance. Remember that in turn will use the person initialization method to create the underlying instance and then assign a unique ID number to them. On top of that, once I've created that instance, I'm going to bind year as a data attribute to the class year of this student. I could, of course, then get back the class year with a getter. The other thing I'm going to do here is I'm going to give MIT undergraduates an ability to speak that's a little different. They are going to use the inherited MIT person speak method. So notice the call. I use MIT person dot speak to get that method that we just saw used from an MIT person. What I'm going to change though is I'm going to add a little bit to what they actually say. And we'll see an example of that in a second. I've got undergraduates. I can also have graduate students. I'm just going to make a separate class for them. And then I want to be able to tell whether I have a student, an instance of that, and here I can use both types to actually pull them out. So I can check for the superclass of is somebody a student by simply saying, is this an instance of an undergrad or is this an instance of a grad student? Good. Let's see what would happen if we were to use this to start building up a little bit of our hierarchy. So I'm going to create some undergrads. I want to give them a class year. I'm going to create a grad student as well. And if I load these in, which I'm going to do now, I can now see what happens with this instant of things. So first of all, let me print out some information, in particular of S1, and I say if I print S1, it prints out the name, Matt Damon. Great. I can also know what class is Matt in, so I do get class on S1, s1.getClass using that getter method. And since it's a method, I do open close paren, and it says class of 2017. Hopefully he'll graduate in a year's time. And then I can use the speak method. And I'll remind you, in my code, I had the undergraduate speak method use the underlying MIT person speak method, but adding something to it. So if I ask Matt to say, speak, where is the quiz? It prints out, Damon says, dude, where's the quiz? So, Damon says came from the MIT person speak method, and that insertion of a dude came from the way I defined adding that to the utterance. And as a consequence, I can have his friend respond with, again, as an undergraduate would here, Affleck says, dude, I have no idea. My point of this is, notice how I'm using the underlying MIT person speak method to do the work, but I'm simply adding something in when this is an example of an MIT student speaking. I can print things out. I can have them talk to each other. All right, what else might I want to know about this hierarchy? First of all, let's remind you what I have here. Here's a diagram that shows what we've built. We have a person. That's my base class. Under that, we have a subclass of an MIT person, and that was where things like the speak method resided. And then relative to that, I can build both undergraduates and graduate students. Now, I haven't done much with graduate students yet. You could imagine they might speak a little differently. They might have other kinds of attributes. And my arrows here are showing the relationship of subclass to superclass and the fact we inherit methods up the hierarchy as we need them. Having built that, I now realize there's another kind of student. A transfer student, somebody that comes to MIT after a year of being somewhere else. So I'd like to add a new class to my hierarchy. I could certainly do it right there. But now I have a problem. I have to rethink is student. Remember, For isStudent, I would simply say, see if it's an instance of an undergrad or grad student. I need to change that. One way to change it would be simply to add another clause to that expression that says, is this a transfer student? But a cleaner way to change it is to realize that I have an implicit class here, and that is a class of student. And let me add that in and show you how it cleans up the hierarchy. I'm going to create another class right up here. It inherits from MIT person. It's a student. They are MIT people. And then I'm going to have each of these subclasses inherit from student. Very straightforward, but it has two nice properties. The main one is, look at what happened to isStudent down at the bottom. It's changed. But before I do that, notice this strange thing in the class definitions. It was in an earlier slide and I didn't say anything about it, but here the special symbol or keyword pass basically says, at least at present, there is no expression associated with that. I'm simply passing through it. And that in particular with student is going to be nice. I don't have any methods associated with student. I simply am passing through, but it's let me clean up the hierarchy. And then finally, notice with isStudent, now it simply is checking, is this a student? If I were to add in other kinds of students here, it's simply a matter of adding the class definition, ensuring that it inherits from student, and I don't have to change the hierarchy or the methods associated with them. So it cleaned up it in a very nice way. And in particular, we can now go back and make sure with that change that we still have the same performance as before, that it will inherit appropriately. And so if I load up a version of that, I can do the same test. I can print out S1, still prints the same way, and I could print out having S1 speak. Where is the quiz? He's still looking for the quiz. Still prints the same way. And if I print S2 speak, again, it still prints out appropriately. Inheriting from the appropriate place. Adding that extra class in there did not change anything because my definitions were still going back to MIT person to get the underlying speak method. If I now look at my hierarchy, I've got person, I got MIT person, I've now inserted a new class, student, in between, and that says it was much easier in this case to add in that transfer student class. And this relates to something sometimes called the substitution principle, that important behaviors of a superclass should be supported by all of the subclasses. And in this case, adding student in as a superclass was gathering all that information together in one place while still allowing us to inherit methods, for example, up here from MIT person.